Hi, welcome back. We are looking at an exponential graph now, and we're trying to graph a transformation of an exponential function. This is number 6 from the homework. So what we're looking at here is the function y equals 3 raised to the negative x minus 1 plus 2. And remember, the first step we want to do is factor out the negative from inside. So I'm going to factor that out, so that I can see really clearly what kinds of transformations are occurring on this function. So we notice that there is a negative inside the argument. Because it's inside the argument of the function, I know it's going to have a horizontal transformation. So this is a horizontal reflection. And the plus 1 tells me it actually will move the graph, translate it to the left by 1 unit. The 2 is not in the parentheses, or it's not in the argument of the exponential function. So this is actually just a translation up 2. It affects the y-coordinate. There's many ways that you can solve this. You could actually plug in numbers for x and then just graph it. I'm going to teach you how to solve it using a transformation so that it mimics what we did with the logarithmic function. So I'm going to make a t-chart of my parent function, which is y equals 3 raised to the x power. And I'll just plug in some numbers for x that I can easily evaluate. 3 to the 0 power would give me 1. 3 to the first is 3. 9, and then we have 27 as some good key points. Now we're going to transform each of these points using the transformations we just discussed. And this is going to be our transformed function, which is the one we are actually being asked to graph. And I want us to look at first what happens to all of the x coordinates. This is going to have any horizontal transformations will change the x coordinates. So the first thing we want to do is the horizontal reflection. And then we also have to move to the left 1, which means we're subtracting 1 from each coordinate. Remember that you must complete dilations and reflections before you do translations. Otherwise, it'll mix things up. So if we have the 0, first thing I want to do is reflect it. It's still 0. I'm moving to the left 1, so I subtract 1. So negative 1. The next x-coordinate is a 1. I reflect it, so I have negative 1, but then I have to move to the left 1, so I subtract 1 again, and I get negative 2. 2 is reflected, so it's negative 2, subtract 1, and we're at negative 3. And finally, the last coordinate was a 3. I reflect it, so I need to give its opposite, subtract 1, and we're at negative 4. Okay, so we transformed all the x-coordinates. Now it's time to transform the y-coordinates. What happened to the y-coordinates is all we did, if you look back at our transformations, the things that affected the y-coordinate was just moving everything up 2, which means we're going to add 2 to each of these coordinates. So 1 plus 2, that gives me 3. 3 plus 2, and I'm at 5. 9 plus 2, we're at 11. And finally, 27 plus 2 gives us 29. So now I have 4 coordinates that I can plot in my graph to help me see what this function will look like. Negative 1, 3, negative 2, and 5. And negative 3 and 11, which we just outside our graph. Before I connect the dots and connect the points to see what the graph looks like, I want to first figure out where the asymptote will be. Remember, for an exponential function, the asymptote is horizontal, and usually it's at y equals 0 for my parent function. But because we've transformed our function, we know that this actually needs to move up 2. So now my horizontal asymptote is at y equals 2. So let's go ahead and draw in that horizontal asymptote to help me remember that my function will approach this asymptote but never cross it. Okay, so our asymptote is at y equals 2. The domain, there are no restrictions on the domain since it's a horizontal asymptote, so it's all real numbers. And the range, however, is restricted because everything, the only y-coordinates we are allowed to obtain are above the value of 2. So from 2 towards positive infinity. To find the key points, we're just going to look at the chart to the right of the transform function and write them as coordinates. You can choose any of these coordinates. It's just a better way to define your function. And there we have it, our graph of an exponential function. Thanks for watching.